Ask anyone convinced we're not alone, and you'll hear some version of the same line. They're here, they've always been here. But here's the thing, after decades of searching, listening, watching and hoping, we have found precisely nothing. No confirmed contact, no verified craft, no signal, no biological sample, nothing that stands up to scientific scrutiny. If aliens have visited Earth, they've done an extraordinary job of leaving absolutely no proof behind. The claims have been arriving for the better part of a century, and not one of them has produced a single piece of evidence that would survive 5 minutes of proper scientific scrutiny. And I want to talk about why, not in a smug or superior way, but seriously, scientifically, because the real answer is actually more interesting and more humbling than little green men ever could be. Let's start with what we actually know. There is no verified, peer-reviewed, reproducible evidence that any extraterrestrial intelligence has ever visited Earth. None. Every piece of claimed evidence, the Roswell crash, the Tic Tac UAP videos, the recent congressional testimonies, has either been explained by mundane causes or remains genuinely unexplained, but completely unverified as alien. Unexplained does not mean extraterrestrial. That's a logical leap, not a conclusion. Think about what a genuine alien visit would actually require. A craft capable of crossing interstellar distances would need to be an engineering marvel on a scale we can barely imagine. It would almost certainly emit extraordinary radiation, gravitational signatures, or electromagnetic interference. We have global networks of telescopes, radar systems, seismic sensors, and atmospheric monitors. We have amateurs with backyard equipment who discover new comets. We have satellites watching every inch of this planet's surface. And yet, every single piece of alleged UFO footage is blurry, ambiguous, and always captured on the worst possible equipment at the worst possible angle. If something genuinely alien landed in a field in Iowa, or in the Nevada desert, or anywhere on this planet, the idea that the entire global scientific community, every journalist, every amateur astronomer, every spy satellite operator on Earth, has collectively missed it or covered it up defies belief. The simplest explanation, as always, wins. We haven't been visited because we haven't been visited. Now here's where the science gets brutal, in the most fascinating way. Even if there are civilizations out there, and statistically there might be, the universe is almost incomprehensibly large, and the distances involved are not just big, they are civilization-endingly, mind-destroyingly vast. Our nearest stellar neighbour is Proxima Centauri. It sits about 4.2 light-years away. That sounds almost manageable until you convert it into real terms. Light travels at roughly 300,000 kilometers per second. In a year, it covers about 9.5 trillion kilometers. Multiply that by 4.2, and Proxima Centauri is around 40 trillion kilometers from Earth. Our fastest spacecraft ever launched, the Voyager probes, travel at roughly 17 kilometers per second. At that speed, it would take approximately 75,000 years to reach Proxima Centauri. Not 75,000 days, 75,000 years. Now imagine a civilization that is far more advanced than us. Let's be extraordinarily generous. Let's say they've cracked 10% of the speed of light, something that our current physics suggests would require energy outputs that dwarf anything we've ever conceived. At that speed, a journey from even the nearest star would take over 40 years. And the galaxy is 100,000 light-years across. Most potentially interesting stars are thousands of light-years away, not 4. A return trip from a civilization 1,000 light-years away, even at 10% light speed, would take 20,000 years. That's longer than all of recorded human history. Twice over. And then there's the energy problem. To accelerate a meaningful spacecraft to even a fraction of the speed of light requires energy on a scale that would dwarf entire civilizations' power output. We're talking about the kind of energy that makes nuclear weapons look like a lighter flicking on. The universe doesn't care about our curiosity. Space is not merely big, it is a near impenetrable wall of physics, energy requirements, and time. But I hear you say, there are hundreds of billions of stars in our galaxy alone. Surely the odds are in our favour. Let's actually do this properly, because the numbers are not what most people think. Yes, there are an estimated 200 to 400 billion stars in the Milky Way. And yes, most of them appear to host planets. That does sound hopeful. But life, as far as we know, needs very specific conditions, and every filter you apply dramatically shrinks the pool. First filter, stellar type. Most stars in the galaxy are red dwarfs, small, dim, and prone to violent stellar flares that would strip the atmosphere off any nearby planet. Sun-like stars, the G-type and K-type stars most likely to support life, make up perhaps 10 to 15% of all stars. That takes us from 300 billion down to around 30 to 45 billion candidates. Second filter, the habitable zone. A planet needs to orbit at precisely the right distance from its star, not so close it bakes, not so far it freezes. This zone is sometimes called the Goldilocks zone. Of all the planets we've detected, perhaps 5 to 20% of Sun-like stars may have a planet in this zone. We're now down to perhaps a few billion potentially interesting worlds. Third filter, planetary conditions. Even in the habitable zone, a planet needs the right size, large enough to hold an atmosphere, small enough not to be a crushing gas giant. It needs geological activity to regulate its climate over billions of years. It needs a magnetic field to shield against radiation. It needs water. Earth's particular combination of plate tectonics, a large stabilizing moon, Jupiter acting as a gravitational shield against asteroid bombardment, and a nearly circular orbit is genuinely unusual. Fourth filter, the time problem. Life on Earth took around 4 billion years to go from single-celled organisms to a civilization capable of building radio telescopes. The universe is 13.8 billion years old, but the elements needed for rocky planets, carbon, iron, oxygen, weren't abundant until several billion years in. Many civilizations could have risen and fallen before ours even began. Temporal overlap matters enormously. Fifth filter, and this is the big one, the emergence of intelligence. Life existing doesn't mean intelligence emerges. On Earth, complex multicellular life appeared relatively recently in geological terms. And technological intelligence, that might be extraordinarily rare. We have exactly one data point, us, and we nearly didn't make it multiple times. By the time you've applied all of these filters, the number of civilizations in our galaxy capable of interstellar travel, existing at the same time as us, and within any remotely reachable distance, could plausibly be 0, or 1, or a handful separated by distances that make contact essentially impossible. This brings us to one of the most chilling ideas in science, the Fermi paradox. In 1950, physicist Enrico Fermi was having lunch with colleagues and raised a simple question. If the universe is so old and so large, and the conditions for life exist in so many places, then where is everyone? If even one civilization in our galaxy had developed interstellar travel 1 billion years ago, the mathematics of expansion suggest they could have colonized the entire galaxy by now. And yet, silence. The skies are quiet. Our radio telescopes have been listening since the 1960s. Nothing. Various solutions have been proposed. Perhaps civilizations inevitably destroy themselves before reaching the stars, the great filter hypothesis. Perhaps intelligent life is simply extraordinarily rare. Perhaps interstellar travel is genuinely impossible for any civilization, however advanced. Perhaps they're out there but have no interest in us, the way we don't radio broadcast to ant colonies. Perhaps the physics of faster-than-light travel is permanently impossible, making the distances permanently insurmountable. All of these possibilities point in the same direction. Don't expect a visitor. So why does this matter? Because there's something genuinely important in accepting the honest answer rather than the exciting one. The universe is almost certainly teeming with chemistry. Amino acids, the building blocks of life, have been found in meteorites. Water ice exists across the solar system. The conditions for simple life may not be that rare. Mars may have harboured microbial life. Europa's subsurface ocean is a serious target for astrobiologists. We may, within our lifetimes, find evidence of simple life beyond Earth. But simple life, a bacterium, a microbe, is not a civilization. It is not a craft crossing 40 trillion kilometres to do circuits over a military base in Nevada. The leap from amino acids to a technological species capable of interstellar travel is enormous, possibly unique to us, and that should change how we think about this planet. If we are rare or even alone, then Earth is not a speck of rock in a crowded cosmos. It is something extraordinary. A place where chemistry became biology, biology became consciousness, consciousness became curiosity, and curiosity built radio telescopes and space probes and asked the question, is there anyone else? The answer, so far, appears to be, not within reach, maybe not at all. That's not a reason for despair, it's a reason for responsibility. We might be one of the only planets in this galaxy where the lights are on. That's not an argument for aliens, it's an argument for taking better care of what we have. There will always be people who want to believe, and honestly, the instinct is understandable. The universe is lonely if we're alone in it. It's a comforting thought that someone out there has figured it out, that we're not just a fluke on a pale blue dot. But the evidence doesn't support it. The physics doesn't support it. The distances don't support it. And the silence of the cosmos, after decades of listening, speaks louder than any blurry video ever could. We haven't been visited. We almost certainly won't be. And the sooner we make peace with that, the sooner we can focus on the genuinely remarkable thing, that we're here at all. Thanks for watching. If this made you think, or argue with your screen, subscribe. There's a lot more universe to get through.